right, for number 17 on 8.1, we're told that the power developed by an electric current, so power, varies directly. That means we're going to have a variation kind of situation as the square of the magnitude of the current. Now, current is measured in amps, and our power is going to be measured in watts or kilowatts. Now, the reason I say that is I've already messed this video up once and I've started over because notice the information that's given. 0.5 amps develops 100 watts. And what I failed to see when I was working this problem the first time on the video, they want to know what current, so the amps is missing, is developed by 1.6, and it's kilowatts, not watts. So 1.6 kilowatts, kilo means 1,000, so that's going to be move your decimal place over three spots, 1, 2, 3. That's going to be 1,600 watts. Now, that's very important because you won't get the right answer if you don't notice that one's in watts and one's in kilowatts. So we kind of have to do that little unit conversion first. All right, this is a variation thing. It varies directly. So I'm going to have the power varies directly. It is equal to some constant times the square of the current in amps. So I'm going to put current squared. Now, you have to first of all know that the current is measured in amps and power is the kilowatts. So you've got to get everything in the right spot. Another thing you've got to know here is you cannot use proportions because this is the square of something. So proportions isn't going to work as well for us. So what we're going to do instead of using a proportion is just do this by saying, okay, they gave me a set of information. They told me that a current of 0.5 amps, so I'm going to plug in 0.5 here. I'm going to put a square on it, generates 100 watts of power. I can solve this little equation and find out what K is, and then I can write the exact equation. Sometimes that's called the particular equation. I can write the particular equation for this word problem, okay? So I have 100 equals K times 0.25 would be 0.25K. That's what 0.5 squared is. If I divide both sides by 0.25, I get K is 400. So my real equation, now I know what the K is. My real equation is P equals 400 times the current squared. Okay, so now if they want to know what's going to give me 1,600 watts of power, that's a P there, the power, I'll plug that in. 1,600 is 400 times C squared. Well, if I want to solve for C, then all I have to do is divide both sides by 400, and I'll get C squared is that's just 4, isn't it? And then if you square root both sides, I don't need to worry about the negative because we don't talk about it in terms of a negative current. Square root of 4 is just 2. So 2 amps is the answer to my question. Okay, so that's how much power a current would generate, 1.6 kilowatts or 1,600 watts. Okay, in 8.1, number 19, it says the volume of a sphere is directly proportional. So volume is directly proportional to the cube of its diameter. So that's diameter. I'm going to put D for diameter cubed. And so there's some number times the diameter cubed. Now what I've written up here is the formula we're used to seeing for volume of a sphere from geometry. And actually they're not wanting that formula here. They're wanting us to develop a formula. What if we plug in the diameter instead of the radius? What's that going to look like? Well, that means the 4/3 out difference is probably going to be something different. Okay? So they say, okay, we're going to help you along. We're going to give you some information. We know the volume is 288 pi centimeters cubed when the diameter is 12. So we can plug that into this little they told us the volume was directly proportional to the diameter cubed, so we know we've got some number out front, K. We've got to find it. And we can find it. We have enough information. We can say, okay, the volume is 288 pi centimeters cubed, and I'm not going to put the units in. And then we've got K times 12 is the diameter cubed. Well, let's see what 12 cubed is. 12 raised to the third power is 1728. So I have 1728 times K is equal to 288 pi, okay? Now probably this pi, we're going to leave the pi in there. Notice that the other formula that we already know has a pi in it, so we're going to leave the pi in our formula too. if I want to solve for the constant here, what number is going to go out front? I'm going to divide by 1728, okay? So remember in your calculator you can say 288 divided by 1728, get that decimal, and then hit math, enter, enter, and it'll actually change it into a fraction for you, a reduced fraction. That's actually 1 over 6 times pi, which would just be pi over 6, is equal to k. So now I know my formula is V equals, my k is pi over 6. I could write 1/6 pi, but I'm just going to write it as pi over 6 times the diameter cubed. Now, let's see, it says, so find the constant of proportionality in terms of pi. So what was k? K was pi over 6, okay? And what was the formula written in terms of the diameter? V equals pi over 6 times d cubed. And so we're done with that one. Now, we were just developing another formula. So if you want a formula where you plug the diameter in, this one is what would work. We just found it.